Diamond can be compressed into something even harder than itself, and scientists already know how to get this material. American and Swedish physicists used quantum-accurate molecular dynamics simulations on a supercomputer to understand how diamond behaves under conditions of high pressure, increased temperature, and instability. They discovered the conditions that bring diamond's carbon atoms into a special, never-before-seen structure. Diamond is considered the hardest material on Earth, but the above structure, called BC8 phase, is 30% harder than diamond. The BC8 phase has been observed in two materials, silicon and germanium. Extrapolating the properties of BC8 in these two materials helped scientists determine how the BC8 phase would react in carbon. The BC8 phase does not exist on Earth, but it is present in space in high-pressure environments on exoplanets. In theory, this is the hardest form of carbon that can remain stable at pressures 10 million times higher than Earth's atmospheric pressure. If we can synthesize it, we will have the opportunity to research and apply extremely valuable materials. Diamond is very hard thanks to its atomic structure. Diamond is arranged in a tetrahedral lattice, each carbon atom within it tetrahedrally bonded to the four nearest atoms, matching the optimal configuration of the outermost electrons of the carbon atom itself. Physicist John Eggert at Lawrence Livermore National Laboratory, USA, said the BC8 structure maintains the tetrahedral shape of diamond but does not have separation planes like in the diamond structure. The BC8 phase of carbon under our ambient conditions is much harder than diamond. But even though carbon BC8 may exist somewhere around us, attempts to synthesize it in the lab have so far failed. The research team led by physicist Nguyen Sung Kien at the University of South Florida, USA, tried to exploit the power of supercomputers to find the errors that prevented them from succeeding. The Frontier supercomputer at Oak Ridge National Laboratory, USA, is currently the fastest supercomputer in the world. With it, the team developed a simulation of interactions between individual atoms under a range of extremely high pressure and temperature conditions. They have recreated the evolution of billions of carbon atoms under extreme conditions. The results show why the synthesis of BC8 carbon is difficult to achieve. We predict that the post-diamond BC8 phase will only be experimentally attainable in a narrow, high-temperature, high-pressure region of the carbon phase diagram, physicist Olyanik explains. In other words, there is only a range of high temperatures and pressures at which BC8 carbon can form, and so far experiments have not met those conditions. However, we now know what those conditions are, and with further efforts to create such conditions and environments, we will be able to synthesize carbon BC8.